Welcome to Know How Tap. This is part 2 of our Service Control Policy Deep Dive. In this video, we're covering the most important exceptions to help you wield SCPs correctly and with confidence. We previously talked about the management account exception, but we will briefly review it here. Next up, we'll talk about service-linked roles. I think these are easily misunderstood, so I'll help clarify what they actually are. And last but not least, we'll talk about how SCPs affect access from AWS accounts that live outside your organization. Everything we discuss here is based on AWS documentation, and I will also leave a link to that in the description. As we discussed in the previous video, AWS Organizations creates a hierarchy using organizational units. At the top of that hierarchy is the root OU. This is the highest level container in the organization, and everything else lives under it. Organizational units can contain other organizational units and AWS accounts. When an organization is first created in the management account, the account itself is placed directly under the root OU. You can later move that management account to a different OU if you so choose. Service control policies are not enforced on the management account, even if they're attached directly to it or to OUs above it. Next, let's talk about service-linked roles. Quick reminder, service control policies set a ceiling on what IAM users and roles can do inside of an AWS account. Another important identity is the root user. That's the one you sign in with using an email address. Inside of a standalone AWS account, there's no IAM-based way to restrict root user actions. Root doesn't have an IAM permissions policy you can review or modify. By default, it has full unrestricted access to everything inside of that AWS account, but that changes with AWS organizations. When an AWS account is a member of an organization, service control policies do apply to the root user because SCPs operate at the AWS account level and affect all identities in that account. In fact, the one thing you can do with a service control policy is to effectively disable root user actions. When you're operating AWS accounts at scale, managing the root user credentials can become cumbersome. When it comes to roles inside of an AWS account, each one will have a trust policy. Trust policy defines who can assume that role, and a role can be assumed by a real person, one of your applications, or by an AWS service. Examples of AWS services that assume roles include Amazon ECS, AWS Fargate, Lambda, and Amazon EC2. So this is where people can get a little bit confused. We say that service-linked roles are exempt from controls that SCPs enforce. Because of that, it's easy to assume that a task role, an execution role, or an IAM instance profile must be a service-linked role, since that role is being assumed by an AWS service on behalf of a container or an instance. But that assumption is wrong. These are not service-linked roles. Real service-linked roles are actually created by AWS directly in your AWS account, using AWS-defined templates that tightly control what permissions the service has inside the account. They exist so AWS services can manage and operate resources in your account, not for your containers or applications to use. I say usually created by AWS because technically you can create service-linked roles yourself using those same templates. But in practice, AWS typically creates it for you when a service or a feature is enabled. Final important thing to know is that service-linked roles cannot be modified. Now, here are a few easy ways to spot a real service-linked role. There's a very specific naming convention. They always start with AWS Service Role 4, followed by the name of the AWS service. If you look at the role's ARN, you'll also see the AWS-service-role in the path. That naming pattern is one of the easiest ways to tell whether a role is a real service-linked role. Alright, the third type of exception we want to cover is access to resources by identities outside of your organization, specifically identities that live in AWS accounts that are not part of your organization. So here we have a sample AWS organization. We've got the management account where the organization was created, and an organization member account that's hosting an S3 bucket. Inside that member account, we also have an IAM user with an identity policy that allows access to that S3 bucket, just like you see on the screen. Next, we attach a service control policy directly to that member account, and as you can see, the user's access is immediately denied as a result. That's because an SCP with an explicit deny overrides any allows granted by the identity policy. Now let's add another AWS account that lives outside the organization. That account also has an IAM user with a similar identity policy that allows S3 access. At this point, that IAM user cannot access the S3 bucket in the organization's member account, and that's expected. In order to grant access from an external AWS account, we need to use a resource-based policy. In that case, that means attaching a bucket policy to the S3 bucket that explicitly allows access from a principal in the outside AWS account with whatever level permissions we choose. Once we attach that resource policy, the IAM user in the external account can successfully make API calls against the S3 bucket in the organization's member account. That access works even though there is an SCP in place that denies S3 actions in the member account. This is where things get interesting. Logically, you might expect that SCP to block that access since S3 is being denied at the account level, but the key thing to understand is where the API call originates. When an IAM user inside the organization's member account makes the call, the request originates from an AWS account where the SCP is enforced, so the request is denied. But when the API call comes from an external AWS account, that external account isn't governed by the SCP attached to the account where the resource resides. As a result, the SCP is never evaluated and the resource policy is allowed to grant access. This is also a good time to point out that service control policies do not apply to and do not override resource-based policies. If you want to limit what resource policies are allowed to do, you need to use resource control policies. Now, the AWS documentation goes out of its way to explain how this works when the request comes from an AWS account outside of your organization. But what if the request comes from another member account inside the same organization and everything else about the scenario stays the same? In practice, the outcome is also the same. And that's because everything still comes down to one question, which is, where did the API call originate? Even though both accounts are members of the same organization, the API call still is originating from a different AWS account. So SCP evaluation works exactly the same way here. Alright, well, hopefully that all makes sense. If it does, leave a comment below and let us know what you think. If you do want to go deeper, check out the other 2 videos in the series. Part 1 dives into the details of how SCPs work, and in Part 3, we walk through practical scenarios where you evaluate requests and decide whether access is allowed or denied. Go check these out, and thanks for watching.